Hello, we are discussing about GATE 2001 ECE paper, and this question is related to digital circuits. For the ring oscillator shown in the figure, the propagation delay of each inverter is 100 picoseconds. What is the fundamental frequency of the oscillator output? So it was given that each inverter is having 100 picoseconds of delay, and we are going to calculate what is the frequency of the oscillator output. So at V0, what is the frequency at this point? Okay, so we know that frequency is nothing but reciprocal of time period, and assume that this is going to be the cycle generated, that is it is going to be the output you are going to get. So it is a clock cycle we are going to generate. So in this one time period is nothing but, if you want to calculate the frequency, let us assume this is the waveform at V0, waveform at V0. So waveform at V0 is nothing but, this is one complete cycle. If you know one complete cycle, at that time frequency at V0 is nothing but, if you take 1 by t, that is nothing but frequency. Reciprocal of time period is nothing but frequency. So one complete cycle is nothing but, the value has to change from 0 to 1 and 1 to 0 and again coming back to 0 to 1. This is what. So 1 to 1, so you must start from 1 and it should go for 0, 0 to 1, again it has to come in this way. Otherwise you can start from 0, 0 to 1 and again 0, it is coming back to 1 to 0. So like this it has to go. One complete cycle is nothing but, you are going to change 1 to 0, again 0 to 1, that is complete cycle. Otherwise 0 to 1, 1 to 0, that is what the complete cycle. Like this you can say, this is one complete cycle. Either way also you can tell. So now we are concentrating on V naught, this node. Okay, assume that at this point the node is going to be at 0. So the value at this point is going to be 0. So at this point now we are in. So the point present is nothing but at this point. Just now it has changed 0. So from this when this 0 will change to 1, how much time the 0 remains at that point, that we will decide first. So this 0 is going to be now available as input for this inverter. Input for this inverter, it will change to 1 after 100 picoseconds, and this 1 to 0 taking place after another 100 picoseconds. This 0 will become 1 at the output of third inverter, that also taking 100. This 1 will become 0 after 100 more, and this 0 now will change this 0 to 1. So the total time it required is nothing but sum of these 5 inverters, 100 plus 100 plus 100 plus 100, that implies nothing but 0 to 1 change, it requires 500 picoseconds. Okay, and now the input for this first inverter is 1 now, because it has changed 0 to 1. So this 1 also, 0 also changes to 1. This 1 will change to 0, that requires 100 nanoseconds. Okay, next 0 to 1 it will change 100 picoseconds of this inverter. Next it will make the 1 to 0, that also takes 100 picoseconds. 0 to 1 it more takes one more 100 picoseconds, and now this 1 is making this 1 to 0 change, that is nothing but 0 to 1. If it has to change, it requires 500 picoseconds. Okay, and this 1 to 0 change takes another 500 picoseconds. 500 picoseconds. So one complete cycle is nothing but total time required for complete cycle. Complete cycle is nothing but 500 plus 500 is nothing but 1000 picoseconds. 1000 picoseconds is nothing but 10 power 3 into 10 power minus 12 seconds. That is nothing but 10 power minus 9 seconds. So frequency is equal to 1 by 10, that is nothing but 1 by 10 power minus 9 seconds, which implies nothing but 10 power 9 hertz. So that implies nothing but 1 gigahertz. So the fundamental frequency of this oscillator is nothing but 1 gigahertz. So the right answer for this question is C. Okay, if each inverter is having 100 picoseconds and 5 inverters are in cascade, by that time the oscillations produced is 1 gigahertz. Thank you.